Hello everyone. Let's discuss the SQL questions asked in the latest InfyTQ sample assessment. But before we do that, let's kind of just quickly revise some of these commonly asked or the common types of joins that you can find on SQL tables. So I'm going to switch over to a couple of concepts here, right? Um, so conceptually joins are really simple. Okay, so suppose you have two tables. The first table is called order, has a couple of columns like this, order ID and customer ID. You have a second table called customers, where you have a customer ID and a customer name. Now one thing that you would notice that is common to both these tables is the customer ID. Okay, the customer ID column, which means if you look at this row here, the order ID 10308, it belongs to customer ID 2. In the other table, the customer ID 2, we can find out that the name is Ankita Sharma. Okay, so joining these two tables effectively means finding out which rows from the first table can be joined with rows in the second table. Okay, that's as simple as it gets. The first type of join, the most common type of join, is called an inner join. Okay, now the syntax for that looks something like this. You would select some columns, few columns from the first table, few columns from the second table. Okay, now what you select depends on what you want out of the query. So I'm going to select a few columns from orders. Now this table, imagine it to be on the left side of a join. Okay, imagine this orders table on the left. Then I do something called as an inner join with customers. So you have your orders table on the left and you have your customers table on the right. What we are going to do with that, I'll explain in a bit, but you get the picture, right? Now, if I had not included this keyword here, if it was just from orders join customers, it basically means it's an inner join. Okay, so if you don't see a keyword there, assume that it is inner join, this particular concept that we are trying to teach. So so the table orders is on the left, customers is on the right, and now I'm supposed to join them. Technically the way you would do it is just take this row here, join it with this row, and this row. So you get three rows from this one row over here. Then you go to the second row and then you join with all three rows. You go to the third row and then you join with all three rows. Okay, but that doesn't tell us anything. So typically joins come with an order. Okay, joins come with a condition. So based on a certain condition, you want to join two rows from two different tables. The condition here is that the customer ID value in the orders table should be the same as the customer ID value from the row in the customers table. Conceptually, this is really simple. What this means is you want to take this first row and then find out whether you can join it with this row. You can't because the customer IDs are different. Then again you take this row, you try to join it with the second row. This time you can join it. So you basically have one row consisting of these four values right now. Okay, then you would go to the third row, can't join it. Then you pick the second row from the orders table, you can't join it with either of these rows. You go to the third and you can't join it with either of these. Okay, so the only row that you have been able to join from the orders table is this row, and the only row that it could join to, which is the only row in the customers table that was part of a join, is this row. Except these two rows, the other two rows in both the tables were not able to be joined. They were not part of a join. They didn't satisfy the on criteria. Okay, an inner join only selects those rows that have made a possible match. Okay, so an inner join in this case will only comprise of this particular combination, 10,308 order ID, customer ID 2, and then it would join with this row. Now since you're joining two rows, technically you have four columns here, but in our SQL query we defined that we only want the order ID from the orders column in this join and only the customer name from the customers column, which is why you see just the two over here. Okay, now the inner join I'll just repeat it one last time, is to make sure that only the rows that find a match, that get matched, only those rows will form your final output. A left join, again, what does that do? First of all, it will find an inner join. Okay, so any row on the left table, the orders table which is to the left, any row in the left table that can be matched to any number of rows on the right table, it will first find out all of those rows. From the previous example, we know that this is the only row that matched for our table. Then, because it's a left join, what it means is any rows on the left hand side table that did not get matched, okay, any rows on the left hand side of the on the left table that did not find a match in the right would still come in the result. Okay, now what this means is this is the one row in the left table which was able to match to the right table, but these two order IDs, okay, these two order IDs for which the customer IDs are in such a way that we can't match it to any of these rows here. In a left join, both of these rows are going to be included in the result. Now, if I include the inner join, I know that I can pick two values from here and two values from the row that it matched to in the second table. But in a left join, these two columns are going to come, and because it did not match with anything in the right hand side, you would typically get null and null for these two columns. It would still try to do what an inner join does, okay, in the sense that it would take these two values, but it would try to find two values here. It couldn't, which is why it will replace them with null. So this is what your final output looks like. Again, we only selected the order ID column and the customer name column. Alright, so that's why this output looks the way it does. The right join, again, it's exactly like the left join in the sense that it's going to first find the inner join. Any row here and any row in the right hand column that can get a match, they will form a row in the final output. And then any row in the right hand table that could not find a match with the row in the left hand table, those rows are also going to get included. The only caveat is, the only difference from left join is, the left join, in the left join, the rows from the left that could not get a match were included. In a right join, the rows in the right table that couldn't get a match are included. So again, the inner join rows are going to always come, and after that, any rows in the right hand side table that didn't get a match, remember originally we had discussed the only rows that get a matching here are these two rows. These two rows don't match on the left table, this row and this row don't match on the right table. For a right join, these two rows are going to come in the final result. If you try to say for this final matched row, if you try to say orders.order ID in a right join, for this row it's going to give you null. For this row it's going to give you null. For this row, because it actually had a match, it's going to give you 10308, right? So this is what a right join is. And a full join basically means you do an inner join, you include all of the rows in that inner join, then you do a left join, you include all of the rows on the left that did not get a match, and you include all of the rows on the right that did not get a match. Okay, the part that did not match will be filled with the value null, N-U-L-L. Okay, so this is the row from the inner join, these are the two rows from the left join, and these are the two rows from the right join. Right, now that we've done this whirlwind tour, okay, just a couple of quick things. If you don't see the keyword outer, okay, in the sense that if the question just says select some columns from a table, full join with customers, that means it's an outer join. Okay, the left join, the right join, and the outer join, all the full join, all these three types of joins are outer joins. Inner joins will never give you null values. Outer joins will give you null values based on which rows in which column, in which table did not find a match. Okay, so now that we've discussed that, let's just quickly go to our MCQs here. Right, so for the following tables. Let's make a quick mental map of what this actually looks like. So there's a table that has ID and name. Okay, so these are 3 students with their IDs 1, 2, 3. These are 5 courses with their names math, physics, biology, and so on. And we have a mapping here that says which student ID took which course. Okay, so this row effectively means that John took the course maths, or number 2 would be Henry took the courses 2, 3 and 4, right? So Henry took physics, biology and chemistry, while John ended up taking math, physics and biology. Okay, so once you form a mental picture of what these tables are and how they relate to each other, it's only after that that you want to start answering these questions. Okay, so let's see. So we're trying to see which query can find out the subject or the course for which no student has enrolled. Okay, so remember, if you want to join all of these tables, okay, if you want to join all of these 3 tables together, what's going to happen? Only the rows that will satisfy student ID is equal to, student dot ID, only those rows are going to get included, and your course IDs, only those courses that can match in a table here are going to get included. If you want to find out those courses that have no students, okay, then effectively what you're trying to look for is some sort of a right join. Okay, so if students is on the left, student course is in the center, and course is on the right, okay, then it is guaranteed that every row in the course table is going to come for sure. Okay, if these rows do not match something else, okay, if these rows don't match to whatever is in the center or the left, then we'll find null values for them. Okay, which basically means if I right join on the table course, if course is my last table that I join, right join, then all of these values are going to get included. Anything that has null for the other 2 tables, what does that mean? That means that for that particular course, there is no student ID course ID pair that basically relates a student to a course. Okay, for instance, if you look at this here, all right, if you were to do a right join of student course on the table course, then these course IDs 1, 2, 3 would join 1, 2 and 3. The course IDs 2, 3, 4 would again join 2, 3, 4. But this particular course number 5, has no matching with student course. So if you do student course on the left, and if you do a right join on the table course, then the 5th row will get included, but the student ID and the course ID values for that matching are going to be null. So that's what we would be looking for. Okay, some sort of an option where the course is on the right and we are trying to see whether the student name is null, or student course dot student ID is null. Any values from the other 2 tables, that would be null. Okay, so let's just quickly go through this. Here we're selecting student, and we're trying to do a left join on student course, and then a left join on course. This is clearly not going to give us the answer, because since course is on the left, it will only those courses will come that will find a match in student ID course ID. Okay, the course that is that no student has taken will not come as part of this. Okay, let's take a quick look at this. So you're doing a distinct course name from student S. Oh, okay, so here you have your course coming on the right hand side, which is what you want. Okay, you're joining it on the right conditions, and here you're selecting, you're basically saying that once you do all of this right join, only give me those rows for which the student name is null, which means there is a course ID record which has no matching with a student ID record. So this is definitely going to be our answer. A full outer join could also give you the answer, But the problem here is now you're saying both student ID is null and the course ID is null, which can't really happen, okay? Because if a course exists, it is going to come in the final output, and your course ID, well, it can't be null, okay? So the only condition that could have been true is if student ID was null. So this query is not going to give you the answer either. So this is pretty much the only query that will, okay? This option faces the same issue. Again, it tries to say that the course name is null, but it can't be, because since course is on the right join, both of these values will always be present. So course.id and course.name will always be present. It's only student ID, student course ID that will be null, and ID and name that can be null, okay, in the final output. So this is our only option here. So we're still working with the same set of tables. We're saying what would the output be for the following query: student S left join with the student course, left join with the course, okay? So what that means is, first we're going to just focus on this part, okay? Remember what a left join is. Try to do a complete matching first, okay? So you want to match this table with this table, okay? So your student IDs John and Henry are going to basically fill in here. So you have John, 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 Henry, Henry, Henry is the set of rows that have matched. What row on the left, student here is on the left, what row on the left did not match with the table on the right? This row, okay? Because there is no student.id equal to 3 that is present in this particular table, because we're joining on that condition, right? So because there is no matching for this row, and because it's a left join, this row will still be included in the final result. So you will have, you know, John, 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 Henry, 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 but you would also have the third row here, 3 Michael. You would have 3 Michael and null, null. Okay, that's how this particular part would be joined. Now in that, you're trying to join course once again, okay? So if you have 2 left joins one after the other, what you can be sure of is that all the rows in student are going to be present, okay? So if you take a quick look here, we know that John, 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 Henry, Henry, Henry is going to be there, and Michael null is going to be there. The second left join is just going to fill in the values for the course name, okay? So this is clearly one of the answers. Again, John, John to John, Henry, 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 and because it's a left join, Michael is going to come in the final output. Here, because Michael doesn't come in the final output, we know that this is not the answer. Here, Michael is the only one coming in the final output. It can't be the case because all of these inner joins, the rows that have already matched, they also have to be present. Be careful, if there is some sort of a where condition at the very end, then it might just happen that we filter out these rows. But for now, because there is no where condition and we are only looking at joins, this effectively means all of the inner joins have to be there, and then one left join, which means one row from the left hand table that didn't find a match, is going to be there. This again can't be the answer because you can't have a student name as null because it's the left table, right? So the null values are going to only come on the right. Here we're doing 2 joins. Now joins, as I said before, are inner joins, which means you're not going to see nulls. This is clearly how it's going to match. These 3 rows are going to match with these 3 rows here, and these 3 and this column is going to match with rows from here. So you're clearly going to have 6 rows in the output. This is clearly one of those answers. Here you don't have any rows by John, so this is not the answer. Again, this is also not the answer because John, all 3 of these rows, John has taken, all 3 subjects, right? Math, physics and biology. So all of those 3 rows are going to come in the final output. And finally here you see course name as null. These are inner joins. They can't have null in them, okay, as a result of a join. So this is not the answer, this is not the answer. The first option is the final answer, right? Now we're going on to a new set of questions. So again, it's some table called customers. It has the list of customer details, and we have another table called orders. In orders, we are referencing the customer by their ID. Okay. So one quick thing to notice, you have about 5 IDs in this table. So this and this will be able to join with the table, with the rows in the customers table, but number 10 and number 9 are not going to be able to join. Okay, these rows will not be able to join with this table based on customer ID. Why? Because there is no row with customer ID 10 in this, right? So this question says, what query would return the orders placed by Thomas Jefferson? Okay, so Thomas Jefferson is my customer ID number 3. Okay, so let's see what they're trying to do. They're saying order date comma amount from customer C, join orders O. So customers are going to join with orders. Okay, based on what? Customer ID has to be equal to order ID, and customer ID is going to be equal to 3. So if this table joins with this table, basically what this means is all the rows that match here with rows that match here are going to come in the final output. So my Thomas Jefferson row matches with this particular row, okay, because the customer ID here and the customer ID here are the same. The customer ID for this row is also the same as Thomas Jefferson. So if you did a normal inner join, you would end up including both of the rows. And then finally you filter out based on customer ID equal to 3. So you would end up including rows like, George Washington based on this order, and whoever is the person with customer ID 2, they would also come in the result. But then after that you are doing a where clause, right? So you're saying customer ID has to be 3 in my final result, which effectively means only those records with customer ID 3 over here are going to form your final answer. So this is clearly going to give you the answer. This is also going to give you the answer. Be very careful. These have really small differences in them. So here you're saying customer ID has to be equal to 3, but this customer ID comes from this column, from this table, the table called customers. Whereas here the customer ID comes from the table called orders. If you were to draw, these joins manually, then you would find out that it's okay if you try to filter both on orders.customer ID or customers.customer ID. Okay, because they would both of these values would come when you join two rows. This cannot be the answer because customer ID equal to 3, SQL will not be able to understand which customer ID you are referring to. Okay, the trick here is you have a customer ID column in the customers table. You also have a customer ID column in the orders table. Now, even though you said that, hey, join on the customer ID column, SQL is not smart enough to understand that, hey, customer ID means in one table should mean the same in the other table. It doesn't understand that. If you just say customer ID, it's going to try and search, hey, which table has a unique customer ID? So there's a customer ID in customers table. Should I use that, or should I use the customer ID in the orders table? Because we did not specify which customer ID to use, this query is actually going to give us an error. Okay, so this is not going to give us the answer. O.customer ID says that I want to filter based on the customer ID value from the orders table, okay, in my final joined row. The next one says, what query would return the days on which no order was placed by a customer in the customers table? Okay, so let's take a look at what they're trying to do here. So they're saying select order date from customers, write join with orders, which means all of these orders are going to come, and any order that does not find a matching customer in this table is also going to come. Okay, so in that case, all we have to do is where first name is null. Now first name, the only place that it comes in both of these tables is in the customers table. So SQL is smart enough to figure out that, hey, first name refers to the values here. If you do a customers right join with orders, all of these rows are going to get included. Any row that does not match, for instance, these three rows, right? Customer IDs 10, 9 and 10. There's no customer ID over here. So when these three rows get included in the final result, the customers.customer ID, first name, last name and email are going to have null values. Okay. So the way we find out days on which orders were not placed by any of the customers that we have is that we first include all of the orders, which means orders either has to be on the left and we do a left join, or it can be on the right and we do a right join. Then we basically say, hey, the customers rows have to be null. If they are null, it means this customer ID I could not find in this table. Okay, so a right join is definitely going to give us the answer. A full join is also going to give us the answer, and in this case both of these options are the same. Okay, seems like a minor typo, but I guess we're going to have to go with all three here, right? So right join is going to give you, and a full join is also going to give you, right? Because a full join is basically a right join. And on the full join, again, you're saying, hey, if the left hand table, which is the customers table, is null, then get me those rows. So it'll get you the orders for which there is no matching customer. Again, here we're trying to do customers full join on orders, okay, which means you will have your inner join. These rows are part of your inner join, okay. And yeah, so you would see that both James Madison and James Monroe, order customer IDs 4 and 5, can't match with anything here. And you would see that these two orders, right, these two orders, number 5 and 6, can't match with any customer here. So if that is the case, then these two rows would be included in a left join, and these two rows would be included in a right join. The values to the left would be null, here the values to the right would be null. In a full join, all 4 of these rows would be included. So you would have 4 matching rows for these 4 for these 4 rows that match between customer and orders, and then you would have 2 more rows from the left and 2 more rows from the right. So in total you would need about 8 rows. The only option with 8 rows here is this one. So that's our answer. It's the same set of tables. Now we're trying to do a right join, which means the values to the left have to be null. Okay, this is clearly an inner join. This is our right join. Okay, this is a left join, and this, as we saw before, is basically a full join. So here we have to do a right join, hence we selected option B. This again is a left join question. We've discussed this before. The only tricky part here is if you went back to the previous example, this is the left join, okay, without any where conditions. Now in the next MCQ, the one that we are about to see, we're only selecting first name and last name, and we would say something like where order date is null. Okay, so what that would mean is we would get this left join first, and then we would say where order date is null. So we would only pick these 2 rows, and out of those 2 rows we are only interested in first name, last name. Hence the answer has to be James Madison and James Monroe, right? So let's see what next. Yeah, so you're doing from customers, you're doing a left join on orders, which means all the customers are going to come, even though they might not match with anything here. And for those 2 rows where the customers are there but they don't match with anything here, these 2 customers, we're going to filter based on exactly those 2 rows. So we would have James Madison and we would have James Monroe. Second last question. Here again we're trying to do a left join, and we've seen this before. We have our 4 rows from the inner join, and we have these 2 rows from the left table, which is the customers table, and the right table, the orders table, because it could not match, it's just going to fill in the null values here. Finally, we look at an inner join. Inner join is the same as a normal join, okay? So this we've also discussed. This is our inner join. Why? Because this row can match with this row, right? Customer ID 1, customer ID 1. You have your customer ID 2 that will match to this row, and then you have your customer ID 3 which will match to this row as well as this row. Okay, so you have Thomas Jefferson making 2 orders, George Washington making 1, and John Adams making 1, right? Any rows that did not match with the orders column from the left hand side are not going to be included. Any orders that could not match with a customer are not going to be included either, okay, because this is an inner join. So now that we're done, let's quickly check what went wrong. So I'm guessing all right, okay, so we mistakenly chose this. If it's a right join, this is when I was trying to show you what to do. So we discussed, right? So right join would have nulls on the left, okay? So this is the one that we want to pick. In the next question, we were doing a left join, which is why probably by mistake this option got selected. But yeah, this is your right join, okay? All your inner joins, and then the rows on the right hand side of the table, which is your orders table, okay? Those are going to come, but since they don't match with anything on the left hand side, you would have null values for any columns that you select from the left hand side table. Right, so that's all from my side. Hope you enjoyed it. If you want, just rewind to the beginning, watch the discussion that we had on joins first, okay? Spend some time on each explanation. I know I probably went through it a little fast. You might have to go through these questions again. It's a little complex, but the tip that I would give you is to first try to do a mental map of how these tables are arranged. Which columns do you see that are common to each other, and then just apply some common sense. Okay, what would a join look like? Okay, this row would be able to join with this row, number 3, this row could join with this row. You should quickly be able to spot, hey, rows 4 and 5 have no way to join with this table, and you should see that, you know, rows 5 and 6 don't have any way to join with this table. As long as you figure out which rows can definitely join, which rows on the left don't join, and which rows on the right don't join, these questions should be simple or straightforward for you. Right, that's all from my side. Have a great day.
Alright, so that was the SQL questions that Abhinandan just covered up. I'll be quickly guiding you through the Python MCQs because they're pretty much similar to the ones that you've encountered earlier. So let's just get started with your Python MCQs right away. So this was the first question that came in the previous mock test. You've defined 2 dictionaries over here, and we're trying to compare D1 and D2. Previously we had done D1 equal to D2 and it was giving us true or false. However, this will give an error because you can't really compare 2 dictionaries like this. You can say whether a dictionary is equal to another dictionary, but you can't really say whether it is greater than or less than another dictionary. Okay, let's go to the next one. A is equal to 5, 6, 7, sum of A and 5. You'll be surprised this actually works. What happens here is it will take the sum of A and it will add it to all of the elements over here. So 5 plus 6 plus 7 is 5 plus 6 is 11, 11 plus 7 is 18, 18 plus 5 is 23. So your answer is going to be 23. What is the case over here? We have A is equal to 5, 6, 7, 8, and then you have 7, 8, 10, 11. And so what A raised to B in this case, what it does is it's a particular set operation, and what it will do is it will join both set A and set B without the common elements. So the common elements over here are 7, 8 and 7, 8. So it's going to join it without the common elements, and it's going to become 5, 6, 10, 11. Okay. Which of the following is not correct syntax for creating a set? So actually all of them are correct syntax for creating a set. This is a wrong question from our side, but all of them are a correct syntax for creating a set. Okay, what will be the following what will be the output of the following Python code? A is equal to 1, 2, B is equal to 3, 4, C is equal to A plus B. So what actually happens here is A plus B is, it's just going to concatenate the 2 tuples. It's not really going to add each value or anything. It's going to concatenate each tuple. And so it's going to become 1, 2, 3, 4. Okay, this is again zip. As you all know, we were discussing about zip last time. Zip basically what it will do is it will create L1 comma L2, right? So it's going to create 10 comma minus 10, 20 comma minus 20, 30 comma minus 20. So x plus y for x comma y in this. So basically it's going to create a tuple 10 comma minus 10, 20 comma minus 20, 30 minus comma minus 30, and for each tuple you're supposed to add the values. So because they are all positive negative values, it will become 0 comma 0 comma 0, because this finally will become a list, right? So 10 plus minus 10, 20 plus minus 20, 30 plus minus 30. Okay, what will be the output of the following code snippet? This is list comprehension. What it's going to do is it's going to go through each element in ABC. It's like a nested for loop, each element in ABC and then each element in DEF, right? It's going to go through that. Once it goes through that one, what it's going to do is it's going to add each one of them and create a list, but it won't be like a 2D list like this. So it's going to be AD, AE, AF, BD, BE, BF and so on, but it won't be a 2D list like this. It will be a 1D list as the one mentioned over here. To remove string hello from list 1, we use which command? You can just use a simple hello command, and simple remove command, and that remove command is here. And this the thing is, these both are same, but this one treats hello as a variable, whereas we want hello as a string. Suppose list 1 is this. What is list of minus 1? It will be the last element. So the last element is 25, therefore it is 25. What will be the output of the following code? Hello name 1 and name 2 dot format. This will give you an error, because when you use a dot format, you would actually require 0 and 1 over here. You can't do name 1 and name 2 over here. What will be the output of the following Python code? Print so and so dot ends with xyy 0 comma 2. So in 0 comma 2, that is 0 1, and we don't take the second element. So it's just 0 1, that is in xy. We want to check if it ends with xyy. It does not end with xyy because we are just checking these two elements. So therefore it's false. ABC space DEF capitalize. So what capitalize does is it takes the first element and it just capitalizes that element. That's it, right? So in that case we have this over here, ABC DEF. Okay. What will be the output of the following Python code? This is a simple print statement. It's going to be D space C space B space A, because the end is a space character. Example is equal to HELLE example dot rfind. So what rfind does, we all remember the find method. The find method finds the first occurrence of E from the start. The rfind finds the first occurrence of E from the end, and so in this case it's going to be 4. It's going to return a positive integer, which is the index here 4. Okay. Print r n hello. So what r does is it prints the raw string without any escape characters. That is, it won't escape the character at all. So ideally, if there was no r, it would print a new line and hello, but we want to print backslash n and hello. Therefore we do r over here, which is a raw string. Okay, list L is equal to list hello. So it's going to convert hello into a list. So it's going to be HELLO. And now it's going to say what you're supposed to do is dot format L. So L is a list which has on the first element H, then E, then L, then L and O. 0 of 0 means take the first argument, which is L, take L of 0. L of 0 is H, comma, then you take L of 2, which is L. So L of 0 is H and L of 2 is L. So it becomes first is equal to H, third is equal to L. What error occurs when you execute over here? So yes, it's an error, but which error does it occur? Well, the error here is name error, because we don't have anything called mango. So therefore it's going to be name error. Why are local variable names beginning with an underscore discouraged? See, generally you use the underscore before a variable to show that it's a private variable. So if you use it for anything else, it's discouraged. It's not that it's not allowed, it's discouraged. So they are used to indicate a private variable of a class, hence it's discouraged. Which of the following is incorrect? Okay, so the trick here is 0. Any number starting with 0 means it's a hex number, right? It's an octal number, not a hex, it's an octal number, which basically means that all of these, this is a correct number, this is a correct number, this is anyways a correct number. Here it's a wrong number because we just gave a 9 here, right? In an octal, you can't have 9 in an octal, right? So 9 will not be possible in an octal because the maximum digit you can have is 8 in octal, right? Yeah, that's 8, yeah. No, actually it's 0, 1, 2, 3, 4, 5, 6, 7. So that's 7 is the highest number that you can have in an octal. All right, let's go to the next one. Which of the following is a truncation division operator? Well, modulo is the double one is the only one that truncates the answer, because generally you'll get a decimal, but because of this you're going to get an integer. All right, let's submit and check whether we made any mistakes this time. Yes, I think we have made a mistake. Let me just check what is the mistake we have made. Yeah, so that is purposely we had left this question out, hence we got 19 out of 20, because actually all of the methods are the correct methods of doing a set. If you try to do this, it may not work. Please do check it out. Maybe it's the correct one. Just do check it out whether this works or not. All right. So that's it from our side. Thank you so much for tuning in, and keep practicing on the mock test that we have coming up. And do look out for the next mock test explainer video. All the best to you. Thank you so much.